Good morning, everyone, and welcome to this lecture. This is Center of Mass lecture number 5, and we are dealing with composite bodies. In the last lecture, we had seen how we can find out the center of mass of composite bodies. Do we remember it? How do we find out the center of mass of composite bodies? Yes or no? We had to break the body into different types of simple bodies, two rods. We find out the center of mass of those rods, and then we can find out the center of mass of the system. We can have a disc or a plate. We can have a cone or a hemisphere put together. In different cases, we had found out the center of mass. Do we remember this? In today's class, what we are going to see is we are going to see center of mass of bodies with holes or vacant spaces. Center of mass of bodies with holes or vacant spaces where we have cut some part out. You can call them truncated bodies. How are you going to find the center of mass of a truncated body? For example, if you have a body like this, this could be a disc with a hole. So I have a full disc, and from that I have taken out some part of that disc. In this case, I have taken out a part which is equal to half of the radius of the disc. Now, first of all, tell me which coordinate of the center of mass do we need to find out here? Which coordinate of the center of mass do we need to find out here? The x coordinate, the y coordinate, or both, or none? Which coordinate I need to find out here for this body? Yes. Which coordinate of center of mass do we need to find out? X, Y, Z, no one. No one has any idea? Okay, think about it and let me know. Okay, so as I got an answer, we have to find out the x coordinate of this only. We don't need to find out the y coordinate. Now, the reason is why we don't need to find out the y coordinate. Why we only need to find out the x coordinate? Yes. Why we don't need to find out the y coordinate? You have to understand the question before solving it. If you don't understand the question, there is no point of solving it. Why we need to find out x coordinate and why not the y coordinate? Answer.
Sir, symmet-
Yes? I'm listening. I repeat my question again. Why do we need to find out the x coordinate? Why not the y coordinate? I'll give you 5 minutes to give me the answer for this question also. The diagram that you see, it has got a symmetry. It is symmetrical about x-axis. Whatever portion is above x-axis, the same portion is below x-axis, and therefore we don't need to find out the y coordinate of the center of mass. We only need to find out the x coordinate of the center of mass. I understand your mic is not working, so I will not now ask any questions. You just have to say this or this, and we will move ahead. The other class I can't see, and I am not able to hear them as well. I hope they are still alive and kicking and in the same universe. We only need to find out the x coordinate of this body. How are we going to find out the x coordinate? Y coordinate we already know will be 0. How do we find out the x coordinate of this body? We are going to assume that this body is made up of two bodies put together. This body is, we are going to imagine, it's going to be made up of two bodies. What are those two bodies? Sorry. What are those two bodies of which this body is made up of? The first body is this body number 1. Body number 1, which I have painted as pink. The first body is this body number 1, which I have painted as pink, which is this body. You can't see the pink color on this. It's already hashed. This is the pink body. This is body number 1. And the other body is the remaining portion, which I intend to paint as green. But this is not the remaining portion. This is the complete portion without the hole. This is the complete body without the hole. Now, how do I make this body from that body? How do I make this body from that body? So I imagine that this body has a positive surface mass density. It has a positive mass plus m1. It has a positive mass density plus sigma. And this body has a negative mass density because it is cut from the same body, so it will have the same density. It has negative mass. One body is having positive mass, and on that I have put another body which has got negative mass. So the result will be the body with the hole. And that is how you create hole in any of these bodies. We don't have to create a hole. We just have to understand how we are going to find the center of mass, how you can imagine that this hole behaves, this body with the hole behaves in such a way that it consists of two bodies, one complete body and one body of the negative mass. From positive mass, if you put negative mass, it creates the illusion of hole. We just need to have that illusion of hole so that we are able to find out the center of mass. Now, since we understand how we get this body, now you can write the formulae for center of mass of this body. The x coordinate of center of mass can be written as m1 x1. I'm just imagining that there are two bodies. Now, plus m2 x2 should be the formula, but here mass is negative. So it is minus m2 x2 divided by what is the mass of the remaining body. It will be m1 minus m2. This is how you can find the x coordinate. If you want to find the y coordinate, same formula. Remember, one of the mass is positive and other mass is negative, and that is why this negative sign comes in between. I hope you understand this. I can't see you, I can't hear you. I can only imagine that you are all doing good. I will give you 2 minutes to note this down. Let me know once you are done in whatever way you can. Well, everyone has done this, so let us now move on and do the same question and see if you can solve this one. So now I have this body, the same body I'm going to put for you, the same body. Now this is a disk with a hole. You can imagine it as a disk with a hole, a uniform disk with a hole. The radius of this disk is given as r. This is how the question would be given. And this portion has been taken out from the disk. It is a uniform disk. Can you find out the center of mass of this disk with the hole? The only information that is given to you is the radius. Rest, whatever is required, you will have to assume it on your own. I'll give you 2 minutes to try this. If you are done, please let me know. If you are not able to do it, then also please let me know, sir, please do it. Then I will do it. I'll give you 2-3 minutes for you to try. If you can get the answer on your own, it would be a tremendous achievement. So I'll give you time. If you're not able to do it, I'll wait for 3 minutes. After that, I will do it. If you are not able to do it, please let me know that you can't do it so I can go ahead and I'll give you the next question. Okay, then. So I will go ahead and do this problem. I will break this up into two bodies. One would be the green body, full disk without the hole. The second one would be a body whose mass is removed, so it will have negative mass. How can I find the area of this body, which is a complete disk? How much will be the area of the how will I find the mass? Sorry, not area. How will I find the mass of this body? Because I will need mass m1. How will I find the value of m1? Yes.
Into area, sir.
What beta?
Rho multiplied by area.
What is rho? This is a disk with a hole. Yes.
Mass by area, sir.
Okay. Mass by area. We call it mass density. I don't call it rho. I call it sigma. Sigma is mass per unit area. So sigma multiplied by area. How much is the area of this? First body, disk without the hole. Yes?
Pi r square.
Pi r square. That is correct. Pi r square. That is absolutely correct. It will have positive area. Coming on to disk. If I call the area of this body as m2, if I call the mass of this body as m2, what will be the mass of this body?
Sigma pi r square by 4, sir.
Minus sigma pi r square by 4. Yes or no? Because it is taken as a negative body. Remember, our origin of coordinates is here. Okay, let us also write the x coordinate of center of mass. What is the x coordinate of center of mass of this body? The original body without the hole. Where is the center of mass of this body lie? Remember, my origin is at the center. Yes.
By 2, sir.
Yes, beta.
R by 2.
Take a deep breath. Deep breath. Open your eyes. Look at the question. Look at where the center is. Look at where the origin is. And then give me the answer. What is the value of x1? I ask you again.
0.
0. So when you open your eyes and you see, look at the diagram and you see, oh, it is 0. Great. Now we jump to x2, the center of mass of this body. Remember, where is my origin? My origin is here. What is the position of the center of mass x2 of the body 2 with respect to the origin O?
R by 2.
Total distance is R. It is center of this. R by 2. Now I am going to put the values in the final formula. X position of the center of mass is m1 into x1, which is 0, minus, because it has to be actually plus, but it will become minus because mass is minus sigma pi r cube by 8. Divided by total mass. Total mass is sigma pi r square minus sigma pi r square by 4. Can you now tell me what is the answer that you are getting? Anyone? R by 6 is what I think you should get with a negative sign. That means the center of mass actually has shifted back. Without the hole, the center of mass was at the center, but with the hole, since I have made hole in the positive half, center of mass has shifted. More mass is now on the left side. The center of mass has shifted to the right side. Do we understand how this question has to be done? Do we understand this, or this has gone above our head saying bye bye? I am going bye bye. I am going bye bye. I am going bye bye. Okay. I'll give you one more chance to redeem yourself. I always believe that students are like cash vouchers. Sometimes they might not work. It's not because the voucher is wrong, it's because I put the wrong code. So I give you one more chance. Now this is the second question, sphere with a spherical hole. Sphere. The diagram is same, but now it represents sphere with a spherical hole. The radius of this sphere is still r. I hope you understand the difference between the two questions. Sphere with a spherical hole, and you have 2 minutes, 3 minutes to give me the answer. If you get any answer, please let me know. If you don't get it, then also please let me know so that we can move ahead. So, how am I going to solve this question? On similar concept, I am going to imagine one sphere, sphere number 1, which is the complete sphere without the hole. sphere number 2 will be a sphere of negative mass density or density superimposed on it. What will be the mass m1 of this sphere? The original sphere, without the hole. Yes. What will be the value of m1?
4/3 pi r cube, sir.
What about rho? There must be mass density also. So rho multiplied by 4 by 3 pi r cube. This rho is mass per unit volume, your original density. Where is the, oh, I forgot to ask, which coordinate of center of mass do we need to find out? Here there are three, x, y, and z. Which one, or which of the one we have to find out? All three, or two, or any one? Which we need to find out?
X-axis, sir.
Only x-axis because it is symmetrical. Okay. Remember my origin is here. Now, tell me what is the x position of the center of mass of this?
0.
0. Chalo. Now we are talking. Let us move on to this body. What is the mass of this one? M2 if I call it.
Rho 5 r rho by 3 pi r cube by 8.
Minus rho 4 by 3 pi r cube by 8 because the radius is half r cube by 8. What is the x position of the center of mass of this
R
body?
by 2.
Now the only thing that remains is to just do the plus or minus. X position of the center of mass 1 is already 0 because m multiplied by any and 0 multiplied by anything is 0, minus rho into 4 by 3 pi r raised to the power 4 by 16. I think you will get divided by rho 4 by 3 pi r cube minus rho 4 by 3 pi r cube by 8. Don't worry about these terms because this 4 by 3 pi r cube, rho 4 by 3 pi r cube, rho 4 by 3 pi r cube is going to get cancelled. Whatever remains would be your answer. What answer are you getting from here? Yes. No one got any answer? I think the answer that you are going to get is minus r by 14. That is what I think you are going to get. And that I will assume is the answer for this one if I have calculated things correctly. Minus r by 40. Is this the answer that you are getting? Yes or no? Or something else? The center of mass shifts on this side and the distance is r by 14. Do we understand how this is done? So any question that comes in this part, in this type, it can be done in this way. Do we understand this, or this has gone above our head saying bye bye? I'll give you 1 minute to note it down. Noted it down? Note it down, everyone.
Sir.
So now this is a question that I have given you. Just to simplify your question, I have already given you x and y axis at that point. So again, what you see here is a L type of a figure. But the figure only exists like this. Only the pink part is there and the other part is not there. So I don't know how you are going to imagine it, but this is the figure and this pink part is the figure. You have to find out the center of mass of this figure. You can take, just for simplicity, your origin at point O, which is the center of whatever it was previously. So do you understand this figure? Yes or no? Then you have 2 minutes to show your talents. Let me color them differently so that you understand that the pink wala thing is the part in which material is present. The green wala thing is the part from which material, there is no material there. You have to find the center of mass of whatever is remaining, whatever it's in the form of an L shape. Let's see who gives me the answer for this one. This is a L-shaped plate. Let me write it also if you want, if you have any confusion. This is a L-shaped plate. No, it is not made up of two rods, remember. Okay, I'll give you 2 minutes to give me the answer. First of all, tell me which coordinate we need to find here. X, Y, Z, both, none, only X, only Y. Which one? Which coordinate we need to find out here?
X and Y, sir.
You need to find out both X and Y. You have 2 minutes exactly to do this. Okay, let me solve it for you. How I'm going to do this? Well, there are different ways of doing it. I can break it up into different figures. I will just do it in one way, which I feel is the simplest. I am going to break it up into two bodies. This is body number one, and this body number one will be a full plate without that green part. I mean, the full plate, and it does not have that vacant portion. If I think it of as a full plate, it becomes a square plate. Yes or no? Do we understand what I am talking about? Do we understand what I am talking about? Full plate without that vacant part. If I call the mass of that one as m1, it will become sigma into a square. Yes or no?
Sir.
The x coordinate of that will be
0.
where? It will be at the center, so 0. The y coordinate will be where? It will be at the center, 0. Yes or no?
Yes, sir.
Then I take this body, which is body number 2. This body number 2 is a body of negative mass that has been put. M2, the value of M2 is the square of side A by 2. So it becomes minus sigma into A square by 4. Do we understand this? Its center of mass lies at the center of this body. What is the x coordinate and what is the y coordinate? Everyone knows the x and the y coordinate. Tell me where is the x and the y coordinate of this?
4.
2.
By 4.
Very good. It will be at a by 4 and y2 will be at a by 4. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye? Then the only thing that remains is to find out the x coordinate of center of mass. The first part is 0. The second part is sigma a square by 4 into a by 4 divided by sigma a square minus sigma a square by 4. Do we understand this? And I think the answer will come as a by 12 minus a by 12. Is it coming as minus a by 12? Yes or no? No, yes.
Yes, sir.
And you will also find out the y position of center of mass. The formula is exactly same. And it will also come as minus a by 12. Is it coming? Yes or no?
Yes, sir.
Well done. If you are able to do this, that means you have understood the concept. This is the most difficult question that can come. Expect a question of this. It may come here in center of mass. It may come in moment of inertia. It may come in gravitation. It may come in electrostatic. The same principle is applicable everywhere. Whenever we have a body with a hole, we are going to create that body in this way. Do we understand this? With this, we come to an end of this part. In the next class, we will be dealing with the motion of center of mass. Right now, we have just found out the position of the center of mass. In the next class, we will go ahead and see how do you find out the velocity, the momentum, and the acceleration of center of mass. That would be in the next class. Everyone has understood what we have done in today's class? Pakka? Okay then, guys, I'll see you tomorrow in the next class, and make sure that your camera is working so that I can see you, so that I can understand whether you are understanding or not. Take care. God bless all of you. Bye bye.